Can you implement a virtualized list from scratch in React.js?
Sure, let me try to remember YouTube video on the topic.
Hello, curious student. So today you and I are going to solve a senior front-end interview question based on virtualized list. So this is a machine coding interview round question, and the question is like this: we need to create a virtualized list from scratch in React.js. So for this, first let's try to understand what is a virtualized list. So virtualized list is similar to how your normal lists are. The only difference between a normal list and virtualized list is, let's just say you have 10,000 items which are supposed to be scrolled like this, and you want to render them. Now in case of normal list, what we do is we append all those elements into the scrolled position, and when we scroll they are shown to the end user. Now as the list grows, or let's just say there are 10,000 or a lakh rows which are to be rendered into the browser, then for every one of those row that you need to render, the DOM elements are getting created, right? So for those 1 lakh rows, the number of DOM elements which will be present in this web page will be very large, and that is where the browser performance will get impacted, and the scroll might get impacted, the browser performance or the website performance might get impacted. So in order to mitigate this issue or solve this issue, what we do is we create a virtualized list. The virtualized list is what? Basically, it only shows the items which are currently present in the viewport or in the current viewport of the parent div, and rest of the items are removed from the DOM, and they are only made visible when user scrolls to them. Now if you see here, there are I guess 6 items here, and if you see the DOM or the amount of elements within this parent div, so this is the parent div, this is the container div which is having those elements, and if you see there are only 1 2 3 4 5 6 7 8 and 9 I guess. So we can see that, scroll below, so there are basically 9 visible items here, and only those 9 visible items are shown to the end user. And when the user scrolls down, these 9 items are itself replaced in the DOM instead of rendering the entire, let's just say 1 lakh or 10,000 rows. And we keep playing around with replacement of these DOM elements instead of rendering the entire 1 lakh rows. And this is the basic idea or basic concept behind a virtualized list. Basically, we keep on replacing the elements within the container element. Instead of showing the entire 10,000 rows, we only show the rows or the elements which needs to be visible towards the current viewport or the current view position of the user. Rest of the elements are hidden or they are removed from the DOM, and they are made available only when user scrolls to them. So that is the basic concept of virtualized list. Now this is a very popular concept which is used in almost all social media websites or any website that you see on the web. They all utilize some form of virtualization in order to make their DOM performant and their website performant, because infinite scrolling is one thing which looks good, but it is very difficult to handle if not optimized properly. So that is where virtualized list is typically used. Now coming to the coding part, we are not going to build a complete list like this because this is a machine coding round. We need to stick to the basics. We need to make a working prototype first, and then we can create the fancy things like this. So let's go back to our code, and let me just open app.jsx, and I'm going to comment out the virtualized list which we just saw, and I'm going to open up a basic virtualized list. Now what do we have in this basic virtualized list is, we have an array of items, so I'm using array.from. They are set to 10,000 elements because let's just say we need to show elements from 10,000 rows to the user, and each element has an item with the index of item. Then we have the item height, so each element or the row height that we have, so these are the elements that are present, and we need to virtualize these elements. So if you see, we have the items here, and those items are basically about 10,000 in length. So if we inspect, we can see only the 12, but basically there are 10,000 items which are present. And what we need to do is, each of this row has a height of, let's just say, 35 pixels. The visible count, that is the visible rows which are present, is, let's just say, 10. And we keep a buffer so that, let's just say, the previous one or the one after the 10th row, for example, the first row and the 11th row, that can also be kept in a buffer. So these are the constants that we first define. We create a virtualized list in basic and we render those items using a map function. So we have a visual items.map, and within that items we have a style in which we have set the item height, which is 35 px. We have a display flex and some properties like background, alternate background color and such. So if you observe here, we have an alternate background color. This is not needed, but if you want, you can add them. And these items that we see, those items are shown to the end users. So just to start from the basics, I'm just going to replace visual items with items, and let's just see if there is any error. Yeah, so let me just comment out this additional code and we'll proceed ahead. And okay, let me just keep handle scroll here. And I think the render is proper. And if we refresh, okay, total height needs to be there. So let's just keep total height. And let's just keep offset y as well. And as you can see, we have the items rendered here. And if we go to the elements tab, and if we click on inspect, we can see that there are almost 10,000 rows which are rendered into the DOM, which is a pretty de-optimized way of rendering the list. And we want to like optimize this, right? So this can hamper browser performance a lot. The memory footprint will be very high. So how do we optimize this? The first thing that we do is we define a start index. So start index is basically the index of the first element which needs to be present in the top of the list. So every time when I scroll, the start index will be, let's just say when I'm at this scroll position, it needs to be 28. When I scroll at this position, it needs to be 57 and so on and so forth. The start index needs to be the starting element. Then also we have an end index which we need to calculate, and we have a state variable to set the start index. And instead of items, we will like show visible items to the end user. So visible item needs to be calculated as well, and we need to set the start index with some value. So that's the overall agenda. That is, from items, we need to like recompute to visible items, and we only need to show the visible items to the end user. So let's just go into the handle scroll element, and this is the base code which we need to first start off. So in case of handle scroll, what we do is we first take the scroll top. Now what is scroll top? Let me just try to log the value first using console.log. Before we go into the start index and other stuff, let me just comment this out. And another thing I need to like tell you is this handle scroll is present in the on scroll element, on scroll of the div. So basically we have a div which has a height, a fixed height. So this outer div that you see, this has a height which is computed, and it is computed as the visible count. For example, the visible count is, let's just say, 10, and the item height which is 35. So this is set to a height of 350 px. If we just go and inspect out this div, let me just go to the top, and this is the transformation div, and this is the, so currently the height is around 35,000, and if you go to the top, you can see that the parent div height is 350 px, which is the height of this parent div. Then we have the child div. So child div has a total height, and the total height is calculated as such. It is the items dot length. So items dot length is around 10,000 and item height is 35. So the total height of the child div is 35,000, which is why we are able to scroll, because the parent div needs to be of fixed height and the child div needs to be of higher height than that for the scroll to work or scroll bar to be present. So the parent div has a height of 350 px and the child div has a height of 35,000, 350,000 px, and we need to optimize the values. Now coming to the scroll top, the parent div has a handle scroll method. And what it does is when we scroll on these elements, it tries to run some code. So let me just go to the top and let me clear the console. So initially the scroll top is 0, that is the value or the scroll position is 0. And as we go on scrolling, the scroll top position gets updated. And this gives us the real time value of the scroll position or the height from the parent or the topmost element into our code. So 7218 is current height and 207 is the index that needs to be shown to the end user. So how do we like come to this value from this height? So for that, what we can do is we can simply divide the scroll top with the item height and we'll get the current index. So let me just comment this out and hit save. And for the sake of simplicity, let me just keep the item height to, let's just say 20. And let me just log out this start index now. Hit save. And the items are a little small, but that's okay. I think I will go with just 10 for even more simplistic code. So they are not visible now, but that's okay. And as you can see, we have the maximum call stack reached. So this is how the items currently are. And we don't want logging, we want console.log. So let's keep it at that. And okay, let's just keep it to 35 for time in so that the browser doesn't complain about the call stack and stuff. So now when we scroll, we should have a scroll top. Let's just scroll. Yeah. So we have a scroll top and we have an index. So how is this computed? It is computed as such. We take the scroll top and we divide it by item height. So item height is, let's just say 35 and the scroll top is currently 888. So when we divide 888 with 35, the output with floor value, which is the rounded off to nearest integer, is 25. As you can see, the 25 is just above this item 26 and that is our start index. Now we can set the start index here so that we start setting the values. For the sake of simplicity, let me just try out with 40 first and check. So let's hit clear and let's just go to the top. Now the browser is a little bit low performance because the values are a lot, and as you can see, this is the actual issue that happens. So now the scroll top is as 420 and the new start index is at 10. Why? Because scroll top is as 420 and 420 divided by 40 is around 10 and that value is returned by the browser, and as you can see the item 10 could be at the top at the current list. So let's just set this to 35, hit save, and we have the start index value. Now we also need the end index so that the browser knows where to stop the values or where to remove the rest of the elements from the DOM. So let's just comment out the end index and let's just calculate the end index as well. So end index is basically max.minimum of items.length minus 1. Basically the last element or the start index plus the visible count, which is the visible count is, let's just say 10. So start index is, let's just say we were at 25. 25 plus the 10 values, which will be the rest of the 10 items, and the buffer that we want, that is the number of elements which we want to keep within the scroll position so that when the user scrolls faster, we at least have those two elements to be shown to the user. So that is the end index. And then the most critical thing is visible items. So visible items are then calculated using the item.slice method. And then we, instead of rendering the item, we render the visible items. So let's just keep it at visible items. And now let's hit refresh. And now as you can see, our browser started performing really well. The reason for this being, if you go to the elements now, and if you inspect the console, you will see that only 12 or 13 items are shown to the end user. And as we scroll, those elements are getting updated instead of the entire list getting updated itself. So this is one advantage which you just saw in real time, that is when the number of list was large, a simple console.log or a calculation position got the React to throw an error that maximum call stack size was exceeded, and that's the one of the reason why we need to make those list performance to reduce the number of computation or amount of computation and optimize the list. Now as you can see, as we scroll, the elements are getting updated in real time and we have a virtualized list. So this is the gist of the values. Then coming to the offset y, basically what we do is we transform the parent div so that the visible items or the elements which needs to be at the top are always like transformed or like taken to the top position of the list. And the total height, as we mentioned previously, it needs to be at 35,000 so that the scroll bar is visible. Now, in this case, then it doesn't need to be that high for a virtualized list, but for the sake of simplicity, we are keeping it to 35,000. And this is the most basic kind of a way to implement a virtualized list in React. So whenever you come across a machine coding round, this is the starting point or the basic version of virtualized list which you should aim for. Now the most important things here was taking the scroll top. You should know that e.target.scroll top gives the scroll top or the current top position of scroll. Then the new start index needs to be computed by dividing the scroll top by the item height, and then we set it to the start index. The end index could be minimum of the last element in the items or the start index plus the visible count plus buffer. Then visible items are basically just a slice of the items which we want to show, and then we show it to the end user. The another important thing is offset y. Now without offset y, let's just see what happens. So I remove the transform, hit save, and as you can see, the list isn't getting shown. The reason for this is because the elements that you see here, they need to be transformed to the top of the div, without which we won't be able to see the rest of the elements because they are not like at the proper position, which is why we needed this offset y. And offset y is basically the start index, which is the element at which the new element start multiplied by item height. Keep in mind that most of the students mess up here. Offset y is one thing which needs to be remembered. It is not something which is intuitive, but you need to remember that offset y needs to be have been there, which is start index multiplied by item height. So this allows the items to be like come to the top or get transformed to the top and then shown to the user. So as you can see, we have the transform here, and then translate y makes sure that the elements which needs to be in the viewport are shown to the end user. And yeah, that is the basic virtualized list. Now coming to the advanced version, I haven't wrote the code for this. This is like I just went to Claude and asked it to create a virtualized list which is more optimized. And the code that you see for the advanced virtualized list, it is generated by an LLM. And in this case, the code has similar principles. It is just a little bit more optimized. That's the only difference. And virtualized list demo has like the items now have the height as random instead of the same height. So if you see here the height that the items have, the container height, no, the item.height, it is a random value which is getting generated. So math.for random, and the height of the elements is now random. We have some colors assigned to each of the items, and the top is set here. So item.top is set into the list. And in the handle scroll, instead of like directly computing the values using set state, which might be a little bit performance heavy, we make use of animation frame. So we use window.request animation frame, and based on that we calculate the function. And in this case, again the logic is similar. We take the scroll top of the parent container element. We set the scroll top because we want to show it to the end user here. So current scroll position, instead of in the console, it is shown into the browser itself. The visible items are shown in the browser as well. And then the first visible ID and the last visible ID, which is just the first and the last element of the or the start index or end index basically, they are also shown to the user. And coming to the logic, it is almost similar. So what we do is we find the first visible item, and it is like instead of like dividing the values, we use max.max, and we like subtract the index I with the overscan. Overscan is basically the buffer here, and the buffer is set to 2, which is above or below the render area. Then we get the visible top from this and start index. Then we run another loop and we get the end index. Now this is a AI generated code, so it is a little bit advanced, but basically this is the visible items of position, in which again we are using a slice method, and we are hitting the item and returning the top items using map function, and then the end values are shown to the user. So basically, this is the more like a presentation kind of a thing. But for interviews, make sure to like first come up with the basic list, know your fundamentals correct, and if they allow you to use like LLMs or AI assisted coding, then you can go for the virtualized list directly. Know the logic, know the concept. You should be able to explain the code nowadays more than writing the code itself, because as I have seen a pattern, like many of the companies are allowing candidates to use ChatGPT and other tools for interviews. The only condition is you should be able to write correct code. You should be able to like see what the problems are when you use AI based code generators and solve them in the real time. Use all the tools that you have at your disposal and come up with solutions to such problems. So that is a trend which is followed by few of the companies nowadays, and eventually it will, I think, get standardized in most of the companies, because instead of like preventing people from using these LLM based tools, they are just like telling you to go ahead and use them, but come up with a better solutions, come up with the optimized solutions. Because front-end development right now is more on AI assisted coding rather than coding from scratch. People are using ChatGPT, people are using LLMs to write better code even in their day-to-day jobs. And you are expected to use the best use of the AI tools, write optimized code. And LLMs have now become the new Stack Overflow basically. And yeah, you can use them at, if you can use them at your work, then it's okay to use them at your interviews as well. But that depends on the interviewer's call. But coming to the interview question for the day, this is how you can build a virtualized list like from scratch or even using LLM. That's up to the interviewer. But you know the both approaches. And that's it from my end for today. If you found this video useful, then share it with your friends. Comment some feedback that you have. Mention some optimized solution that you can think of. And subscribe to the channel for more such content. And that's it from my end for today. Thank you. Have a nice day. Goodbye.